Learning, memory, and communication. How does it relate to our brain? To start, I would like to discuss the parts of the brain that would be considered vital when it comes to communication, learning, and memory. Memory, learning, and communication go hand in hand, but each one has its own set of processes and parts of the brain that makes them do what they do best. Let's start with learning. What is it and which parts of the brain are important when we learn? It's safe to say that we learn something new every day, but how does it look on a neurological level? Have you ever wondered? Let's start with learning and memory. What is learning? Learning is the acquisition of knowledge or skills through experience, study, or by being taught. There are two key regions of the brain that is vital when it comes to learning and memory, and that is the amygdala and the hippocampus. When we learn something or experience something new, there is a change in our nervous system and our behavior. Learning alters the strength of our weight of the synapses. Changing the strength or weight of synapses changes the functional architecture of the brain. Experiences also have the ability to change the way we perceive, perform, think, plan, and behave. Isn't that interesting? You're probably wondering what types of neural activity is going on in the brain when we're experiencing or learning something. Let's explain further. The hippocampus in the medial temporal lobe is a crucial brain area for learning. It's been discovered recently that the adult brain has the ability to produce new neurons via the hippocampus. Wow. Just listen. When we thought that the brain couldn't produce new neurons, we found that we could. At the most fundamental level, learning is a process by which experiences changes an organism's responses. There are two low-order mechanisms by which neural responses change, and that is adaptation and facilitation. Let's talk about the definition of adaptation. Adaptation is the reduction in firing of a neuron over time, despite a constant input or, in case of habituation, when stimuli are repeated. Adaptation occurs throughout the nervous system. You can easily identify adaptation in sensory systems when something you hear, see, or feel is quite noticeable initially, but becomes unnoticeable over time. Facilitation, however, is the opposite of adaptation. Facilitation occurs when a neural response increases over time or after repetitions. Facilitation is often associated with stimuli that are slightly noxious. Noxious means harmful, poisonous, or very unpleasant. Both stimuli from the external environment and internal sources trigger activity changes. With learning comes memory. There is a simple process to explain how it works. It happens in 4 steps. First, we encode, which is learning. Then we consolidate, which is memory. Then we store, which is memory. Then we retrieve, which is memory. So we have encoding, consolidation, storage, and retrieval. Encoding is the learning aspect, while consolidation, storage, and retrieval all deal with memory. With memory, we have long-term memory and short-term memory. Let's talk about how it works. Short-term memory exists in 2 places, the lateral prefrontal cortex and the hippocampus. Neurons in the lateral prefrontal cortex maintain their activity, representing an input after the input has gone so that we can use the memory to accomplish a relevant task. What the hippocampus does is provide a set of modifiable neural and gates for neural activity. These hippocampal and gates receive input from the entire core as it represents what is going on in the current situation. The activated NMDA synapses then strengthen the synapses that represent all the cortical activity associated with any particular situation. When it comes to learning, memory, and communication, it's a cortical process. The posterior association cortex is involved with perceptions and memories, and the frontal association cortex is involved with plans for movement. I feel that we can say about the environment as it relates to stimuli for learning and memory is that the environment plays an important role in our learning and memory. The environment has contaminants that can harm the IQ of an individual, and it's safe to say that a bad environment will produce negative learning and memories. However, on another note, we can conclude that a good environment is good for healthy learning. Language and communication are important aspects of human social behavior. Communication can call for a cortical and subcortical process. In the case of language, brain regions are distinguished based on function rather than neuroanatomical differences. The left hemisphere of the brain is dominant for speech and language functions. Neural circuits play a major role in communication as well. There are primary circuits located in the left hemisphere of the brain that plays a major role in speech and language. When we hear or talk, we are using neural circuits. To be precise, both hemispheres of the brain contribute to our language abilities.